Hello and welcome to Group 17's capstone project presentation.
Okay, so let's start with the introduction of who Vantage Plastics is. Vantage Plastics is a plastics manufacturing company that was started in 1996 in Standish, Michigan. They specialize in thermoforming and extrusion, and at their 170,000 plus square foot facility, they have one of the largest thermoforming machines in the world. Vantage is a vertically integrated company that controls their own regrind operations. They grind up and recycle the plastics from old materials in excess to remanufacture the plastic sheets for their thermoforming machines, lowering their production costs. Our project focus is specified towards a new material they use to manufacture pallets for automotive component transportation.
The material that we're working with is Vantech, which can be seen as the green material in the photo above. Vantech is exclusively used and was designed by Vantage Plastics. As you can see, it's very thin, and it's typically only 30 thousandths to 60 thousandths of an inch thick. The Vantech material is composed of calcium carbonate, talc, and carbon fiber. Vantage uses twin sheet thermoforming, and they're able to create a pallet with high molecular weight polyethylene with a thin layer of Vantech on top. Vantech material is important in the reduction of chafing between the parts in the pallet, which leaves unwanted plastic contaminants on the customer's parts. Vantech has the ability to absorb different unwanted forces, which helps during transportation and can save customers time and money.
The issue Vantage Plastics approached us with is this excess edge on the Vantech material. Pellets are removed from the thermoformer, and an employee currently uses a pneumatic hand router to go around the part, leaving an undesired burr on the finished material. This has proven to be both time consuming and it requires the use of an open flame to heat the material, which they are trying to move away from. We reconstructed the problem using the CNC mill to cut 4x4 test blanks of the material, varying the speed to observe how the Vantech burrs with the cutting edge and flutes to emphasize the issue we're dealing with. All Michigan Occupational Safety and Health Administration and International Organization for Standardization standards need to be considered for both our customer and our group to follow. NEOSHA Standard 1126, which is General Industrial Safety and Health Standard, along with NEOSHA Standard 1128, which is hand and portable power tools, must be followed. These standards both ensure the health and safety in the workplace. And then ISO 13399-1 states the fundamental principles for cutting tool data, representation, and exchange. This standard just covers any transferring of cutting tool data between us and Vantage Plastics.
Something we considered early on in this project was the use of a nibbler. A nibbler is going to utilize a punch and anvil, which gives us a localized shear force with a good control edge. An electric nibbler is going to oscillate at about 230 to 370 RPM, which chews through the material like a rodent. They're considered very fast and versatile, especially when compared to similar tools like shears. They do result in vast chip formation, but given Vantage Plastics' current solution using the hand router, this difference is pretty negligible. However, because nibblers are typically used to cut 16 gauge sheet metal, large capacity nibblers come at a price tag. It requires the use of a high-end industrial nibbler coming in at about $3,000. For that reason, they weren't explored further.
While doing research into how the industry goes about cutting composite materials, ultrasonic cutters are a commonly used method. Depending on the application, they can be used anywhere from cutting your Thanksgiving turkey to gate cut resin molded products. It functions by oscillating a blade at a high frequency of about 20,000 kilohertz. The vibration is microscopic and is virtually invisible to the eye. The ultrasonic cutter is extremely versatile in use, which can be used by hand, robotic arm, or CNC. The downside of using this method is that although industrial cutters will give the cleanest edge, they are extremely expensive, ranging from $15,000 to $20,000 for a single unit. Also, we are unsure what the wear of the cutting edge will be over time, leaving us with long-term cost concerns for the blades and maintenance for the machine.
The current technology being used to cut this material is a pneumatic-powered hand router. Currently, this tool is being used for the low cost and fast-running nature of the operation. The main issue with this method of cutting is that the Vantek material is leaving a large undesirable burr on the surface of the cut plastic. Vantek is applied to high-density polyethylene base layer in the thermoforming process. The main goal is to achieve and implement design change that would be a seamless transition to what they already are currently doing. Currently, Vantage Plastics is using the LMT Onstrad RTC 58-2022 straight cut O flute style routing bit. Although this tool is very cost effective and American made, it fails to deliver the result that Vantage requires in the cutting of the material. In our research, we found there's a limited number of companies that specialize in this specific style of tool. The main goal of using this technology is to provide the seamless transition and adaptation. The hand router itself works to expectations, running up to 20,000 RPMs, and very easy for operators to use. Researching and finding a cutter to deliver the results will be ultimately the most viable option for the company. When the best cutter for the job has been selected, longevity and tool life will be of the highest priority to keep the solution cost effective in the future. Next.
Due to the unfortunate circumstances of the COVID-19 pandemic, our spring semester and subsequently our capstone project was interrupted. Since testing was not possible with the school shutting down, we have decided to give recommendations of how to move forward. It is important to note that the MIOSHA and ISO standards for processes, safety, and data representation is diligently followed and to document all further steps. By utilizing the Taguchi method, the dependent and independent variables can be identified and rated. Then, calculate the cutting force between an end mill and the workpiece, identify the formulas for rotary cutting and machining, and analyze the data produced.
In our experimental process due to the pandemic, we weren't able to actually perform the experiment ourselves, so we are going to give recommendations on how to select a end mill and router bit for this unique cutting situation. Since this material, Vantek, is very unique and is new on the market, there isn't any set companies that make a router bit for it. So we've had to look and research router bits that work in similar types of plastic. We've determined these rules of thumb to help in experimenting and finding what cutter will work the best. Should always consult the machine operator's manual for the capacities and recommended feed rates. We used 100 inches a minute because it best represented a operator moving through the material manually. We should also start with shallow cuts and calculate chip loads and speeds and feeds with the given formulas. Next slide.
We applied the Taguchi method to guide our experimental process. With multiple variables such as the temperature of the material, the end mill RPM, and feed rate, it can be hard to gather enough data to properly optimize these variables. Taguchi method utilizes an orthogonal array to set up multiple testing levels for the variables and what levels to test at during experiments. The effectiveness of variable changes can be explained using the signal-to-noise ratio.
The signal-to-noise ratio is an important factor because this will help identify key variables and prioritize them. When the variables are identified, the uncontrollable variables are minimized or even eliminated. This will help greatly improve the cutting solution. Next slide. So as you can see in the table on the left, the three variable parameters that we would have tested at are RPM, feed rate, and the temp the material was when it was cut. The table on the right would be the performance outcomes of each test, which will give us the most effective combination of the cutting parameters. Next slide. So unfortunately, due to our current situation, we were unable to physically test our solution, but adapting to the changes, we were successful in changing our report into a consultation. We are confident that our consultation will best set up future engineering groups to successfully find a solution for cutting. Thank you.